name is Anna Kuparinen. I work at the University of Jyväskylä in central Finland. My project is titled Complex Ecoevolutionary Dynamics of Aquatic Ecosystems Faced with Human-Induced and Environmental Stress. So I work with complex food webs. And what I mean by complexity, I mean a large number of species and large number of interactions among species. These interactions in this figure to illustrate feeding interactions, so predators eating smaller items, and on the other hand, in the very bottom of the food web, producers producing energy through photosynthesis. My project has the key objective of integrating evolution into the understanding of complex aquatic food webs. So our start point is the evolution that takes place at the level of individuals. Individual life history traits change, they modify populations, and through predator-prey interactions affect the ecosystem dynamics. These internal predator-prey interactions form the natural selection in the system and again shape individuals and species evolutionarily. But then we have also the human-induced component. There is fishing, there is probably also other disturbances such as pollution, temperature changes through climate change, or habitat destructions. We try to capture the complex dynamics of aquatic ecosystems with the help of mathematical simulation tools. So we have set of differential equations and we have functional responses that define how much energy moves between each predator-prey interaction. But we also try to build in the evolution into the system. And we do this by splitting each node in the food web to separate gene groups that then control properties of the species. Here in this simulated example, we have an evolving fish. It is exposed to fishing for 50 years, and these heat maps show the distributions of two life history properties, juvenile production of the fish and the fish maximum length. In the beginning, the highest row describes the situation driven by natural selection, whereas the two rows in the middle tell about the situation when fishing has started and it starts to truncate the largest individuals away from the population and also increase the investment to juvenile reproduction. Once fishing is ended, the fish length and juvenile production slightly recover, but the recovery is not fast. It happens slowly because natural selection is not as strong as the fishing-induced selection. To communicate this mathematical knowledge we produce to the society, we have developed a computer game where the player can choose which species to fish and using which fishing gear and fishing intensity. And then the game explains how the fish biomasses are developing. And also the player can go and see how are the invertebrates in the system doing and how are the other algae in the system doing and how the kind of general indicator of the ecosystem health is doing. And the player gets scores when he or she manages to keep the fish biomasses at the sustainable level. But if fish become overfished or even population crashes or goes extinct, this costs a lot to the player. So of course, the winner of the game is the one who manages to get as much as possible fish catches, but at the same time do it in a sustainable way. In the end, I would like to acknowledge my funding sources and Water JPI program for providing a nice network where to talk with other scientists about my work. Thank you.
All right, I'm Kate Schoenrock, the PI of Kelp Res, where we study the diversity and resilience of kelp ecosystems in Ireland. I'm just going to briefly run through our project. So we're interested in the historical distribution of these kelp forests in order to track their movements with the climate change. Also, the genetic or the evolutionary resilience of these populations. What's the genetic structure and connectivity? And are there areas of high diversity hotspots that might need conservation efforts in the future? And are there ecological metrics that are used to help kelp forests be more resilient? So, for instance, banks of microalgal stages, analogous to seed banks in grassland habitats. And then lastly, we really are interested in monitoring these marine communities moving forward, whether that be through remote sensing or potentially recreational divers. This would feed back into historical data sets for kelp forest distribution. Kelp forests provide structure, food, and protection for marine and coastal ecosystems. So they're really important ecosystem engineers that support coastal communities across Ireland. We are really interested in using the ESA approach, and what we need to do moving forward is translate the impact of kelp forests, for instance, on human well-being, service provision, for instance, fisheries, create more synergies with social sciences and other disciplines to kind of visualize how kelp forests might be important for human condition. Again, they're subtidal communities, so a lot of people wouldn't see them unless they're swimming. And then lastly, we really need to kind of provide indicators, use our data, and translate it easily so that people can use it in making policy making and decisions about how these communities are conserved and so on. We've been working with AQUATAP throughout our grant. It's been really nice. We've been able to contribute to discussions about research and infrastructure, as well as policy documents and papers. It's given us a lot of good insight into ecosystem services across a lot of aquatic habitats. And we hope that we can contribute to future working groups, but also that we can incorporate more coastal projects, as there's a lot of synergies between marine and coastal communities. So thank you.
My name is José Badoque, and I am the principal investigator of the Renaissance project, which is being funded by the Spanish Research Plan. The main objective of our project is to model lateral connectivity in the river floodplain system, with the aim of characterizing the impact of such connectivity on flood risk mitigation, on the water status of water bodies, as well as on the conservation of ecosystem services associated with freshwater aquatic ecosystems. To address this objective, we are working on a reach of the Douro River long enough to assess the efficiency of the alluvial river aquifer interest. Also, the project has the engagement of some of the key stakeholders concerning the management of aquatic ecosystem, such as the Spanish General Directorate of Water, the River Basin Authority, and practitioners related to water resources management. Additionally, the project is being developed from an interdisciplinary approach. To this end, the Renaissance has experts in flood hazard and risk analysis, river restoration, social perception analysis, vulnerability analysis, and in the characterization and economic evaluation of ecosystem services. In my understanding, the main difficulty in implementing the ecosystem services approach in the everyday management of our waters has to do with a huge number of scientific papers that have been published following different approaches concerning ecosystem services science. This lack of consensus in the scientific community hampers practitioners and decision makers to implement ecosystem services approach. For our project, involvement in AQUATAP has been very important, as this has enabled us to have a much more integrated view of how to implement ecosystem services approach in freshwater aquatic ecosystems. In my opinion, the best way to foster continuity of the AQUATAP network is to promote the preparation of proposals to be submitted to European calls under the European Horizon Programme for Research.
This short presentation gives an overview of the ES-Decide project, which is based on River Ecosystem Services. Our interdisciplinary project team has expertise in water quality, ecology, hydrology, modelling, and environmental economics. We are building a decision support tool to enable end users to consider ecosystem services in river resource management. We are also exploring how the values held by people for rivers can be incorporated into decision-making for improved water quality. At the heart of our decision support tool is a Bayesian belief network model. We've gathered data from national monitoring and we've gathered information from scientific literature and experts. We then use this knowledge to link pressures from human activities such as siltation, organic pollution or removal of bankside vegetation with a range of benefits or ecosystem services that society derives from rivers, such as good quality water for drinking and recreation, angling or wildlife value. A web interface has been designed that allows end users to interactively access the tool via standard web browsers. The user's selection of changes in environmental conditions is subjected to the Bayesian belief network that runs in the background of the web interface. The model changes of negative and positive effects on ecosystem services are then displayed in the bar chart on the right-hand side. The decision support tool thus supports decisions on management options required to benefit ecosystems and their services to humans. In parallel with the decision support tool development, ES-Decide has engaged with citizens to consider a range of dimensions relating to how people might value rivers. These include transcendental values, which are people's overarching principles and life goals, and are the basis for people's deep-held values, such as not polluting rivers, while contextual values are the values people hold for a particular river at a particular time. For example, the joy of seeing a fish swim in a river. Value indicators are measures of value, which include monetary measures as well as socio-cultural indicators. We also consider different justifications for values, including instrumental, relational, and intrinsic values, and whether values are best incorporated into policy decisions as individual values or shared values across society. The ES-Decide project demonstrates that accounting for the multiple values of river services in decision-making is likely to promote equity in the resulting policy. Thank you for your attention. For further information, please visit our website or contact any member of our project team.